Today's free response question is from the 1995 AP Calculus exam number 5, or on the BC test number 3. I've categorized it as a type 7 question, the calculus grab bag, because it focuses on related rates, which is not covered in any of the preceding 6 topics. So let's take a look at the question. As shown in the figure above, water is draining from a conical tank with a height of 12 feet and a diameter of 8 feet into a cylindrical tank that has a base area of 400 pi square feet. The depth h in feet of the water in the conical tank is changing at a rate of h minus 12 feet per minute. And then they provide us the added insight that the volume of a cone with radius r and height h is v equals 1/3 pi r squared h. So with the cone, all cones, typically you're going to have a problem that relates the radius of the cone to the height of the cone. So a relationship that we can write is the radius to the height is going to be of the proportion 4 feet to 12 feet. Alternatively, we could write this as 12 radiuses equals 4 heights, or we could reduce that down to 3 radiuses for every height. Okay. Questions on that? When they ask us to do a problem, they're going to ask us at the height of 3 units, and they tell us that the rate of change of height, dh dt, equals h minus 12. So that's the given information for the cone. Okay. The given information for the cylinder, well, we know that volume of a cylinder, or extruded shapes, right extruded shapes, is base times height, or pi r squared times height if we are playing with radius. But the problem they give us is they actually tell us the area of the base is 400 pi. And so that base area isn't changing. So you could say volume of the cylinder is 400 pi h. Okay, so keep in mind that this information here is for the cone only, and we might as well write the volume of the cone equation 1/3 pi r squared h in case we need that, and this is information for the cylinder. Okay, so part A asks us to write an expression for the volume of water in the conical tank as a function of h, and that's the key word right there, as a function of h. We already have an expression for the volume of the cone as 1/3 pi r squared h. They kindly provide us that in the context of the problem. This is a volume expression in terms of r and h. We want it in terms of only h, which means we have to get rid of that r. Well, if we established earlier that 3 radiuses is equal to a height, or 1 radius is 1/3 of the height, there's our relationship of writing r in terms of h. So we can replace the r to be 1/3 pi, and then we replace r with 1/3 h squared h. And right there, you have answered the question part A. Though I think it's worth simplifying, since you're probably going to do some further work to it, and the simplification for that is 1/27 pi h cubed. Moving on to part B. At what rate is the volume of water in the conical changing when h equals 3? So they're asking us to find dV dt. What is the rate at which the volume of water is changing? And dV dt is found by taking the derivative of your volume equation with respect to time. So the derivative of volume is dV dt. The derivative of this expression is going to be 3/27 pi h squared dH dt. So dV dt equals 3/27 reduces to 1/9 pi h squared. Since h is 3, we're going to do 3 squared. And then dH dt, we established above, was h minus 12. So if h is 3, 3 minus 12 is negative 9. This 9 cancels with that 9, and we get negative 9 pi. So at what rate of the volume of water in the conical tank changing when h equals 3? Indicate units of measure. So when h equals 3 feet, the volume in the conical tank is decreasing by 9 pi cubic feet per minute. All right, on to part C. Let y be the depth in feet of the water in the cylindrical tank. At what rate is y changing when h equals 3? Indicate units of measure again. So we need an equation that measures the depth of the water. This rests on going back here to our relationship that exists in the cylinder. V equals 400 pi times height. Now it should be noted that the height being used here is the height of the cylinder. It's not the same h from above. So really we should assign a different variable to this. And the variable that they ask us to use is let y represent the depth of the water in the cylinder. So we now have an equation from that using y to reason with depth. This was the general formula for a cylinder. It is important to know that the h is not the same h from above. So we have an equation. V equals 400 pi over y, or times y, or we could rewrite that as 1 over 400 pi times v equals y. This is our equation that models the depth of the water in the cylinder tank. And they're asking us to find dy dt. So this is another related rates problem. We need to take the derivative of both sides with respect to time. So the derivative of the left-hand side is 1 over 400 pi times dv dt. And the derivative of the right is dy dt. They indicate to find the measure when height equals 3. So that's using the rate of change of volume from part B. If 9 pi units of water are draining out of the cone, that means 9 pi units of water is draining into the cylinder. So our change of volume in the cylinder is 9 pi. So we can replace dV dt with 9 pi and get our dy dt. The pi's cancel, and you get our answer. When h equals 3, the depth of water in the cylinder is increasing 9/400 feet per minute.